So let's get each of you to introduce your role. And do you want to come up, Rajiv? So I think you've got the pictures of all the people there, but working with Don, we actually have Michael Bartlett. I think Don mentioned IOTA View, and the company is IOTA Software. So do you want to introduce yourself?
Sure. Hello, everybody. My name is Mike Bartlett, and I think I found out from Ibrahim that I'm part of the technology mafia now. So I think that's pretty cool. I don't know if that's a good or a bad thing. But IOTA Software is a visualization software that allows technology companies, manufacturers, utility companies to kind of put a foot in both OT and IT. So, born out of, the likes of OSI Soft and Seek in focusing in the OT space, allowing users to bring all that information in a near real-time way and all the insights from applications and platforms like Seek, as well as applications in the IT space like Databricks, Snowflake, kind of the representation that Don had, and putting that into more of a single pane of glass, right? And so Don showed those cool 3D graphics, our team helped put together. So it's kind of, putting a spin on the traditional, operational visualization and kind of making it more rich and enhanced.
Great, thanks. Lucas, why don't you go next and what you've been doing with Ibrahim and the team?
Yeah. So I'm Lucas Oliveira. I'm account manager with Radix. I'm working closely with Ibrahim and leading our development teams that are working on the Celanese program.
You're working with Radix as well, didn't you say? Yeah, all right. And Rajiv from Parabol. I always say Parabol, but it's parabol.ai, right? It should be on. Oh, that one isn't. Okay.
Hello. So this is a tough task. So I'm representing both Parabol and Cummins. So I'm Rajiv Saha, co-founder, CEO of Parabol. So we offer a causal AI analytics platform for the manufacturing setting. We work with mostly the process and batch manufacturing companies, like in that industrial sector, industrial energy sector, and also started working with this automotive sector. Cummins is our first partner in the automotive sector, so which has implemented this solution for their production planning. So it is one very unique example of, or unique case for this multi-objective optimization for their one of their manufacturing plant.
Okay, thanks. Is there any questions out there, or I'll kick things off if no volunteers? All right, Alex at the back there. Oh, there's one right by the exit over on that side. And if you can just tell us your name, which company you're with, and if you have the question targeted at a specific individual.
Sure. Ashley Kuno with Buckeye Partners. I was really, really interested in the work that Celanese the presentation of all the features with the pump troubleshooting, with the cavitation, as well as like with the damage and being able to figure out a repair plan and stuff. So I just wanted to, from what I understood, like it kind of was looking at your maintenance records, it was looking at your P&IDs and kind of leveraging the understanding of the system to be able to come up with some of those troubleshooting capabilities. Like what kind of knowledge did you have to kind of build into that, and like what was kind of company knowledge or maintenance records, kind of what did you have to do, and like how much went into being able to build it to be able to get to that point? I know you mentioned you've got quite a few users using the system, so I'm sure over time it's kind of learning from that experience and you're putting some inputs in, but just a little bit more elaboration on that would be very interesting.
Yeah, I think that was for you.
Okay, I will get Lucas to give more technical details, but what we've done is the troubleshooting, for example, is leveraging the data that's on our platform, right? So that includes work orders, P&IDs, all the contextualized components that are involved in that. Now, it's not what troubleshooting is targeted to specific data sets, and it picks out whatever in the knowledge graphs that is relevant for the troubleshooting. The other thing that's embedded in the troubleshooting agent is knowledge from our rotating equipment engineers, right? So actually, we spend time interviewing knowledge from the troubleshooting or from the rotating equipment engineers, and actually embedded that as part of the agent, so that one of the things that we also have is this Joe AI will also be a key piece of what I call knowledge retention, as talent, attrition or leaves or whatever. So that's some of the things that we did. And combination of that plus our data is what you were seeing on display.
Yeah, there is not much to add, but I think there are two components. One is the static knowledge, and that's what Ibrahim mentioned about like interviewing the rotating equipment engineers, translating that into the knowledge graph as well. But also the real-time data, right, that can influence on the knowledge graph, how we prioritize the steps, how you provide more visibility about what can be the potential root cause analysis, right? So one is influencing the other, and both are being analyzed by the troubleshooting agent, depending on the question, depending on the context, and the equipment that you're looking for, right? And what's the history, all of the variable information that changes and gets updated pretty much every day, or depending on the time series every second, right?
Okay, thanks. Knowledge graphs have come up a couple of times, right? And I'm not sure everyone understands the role of the knowledge graph in creating all that contextualization and being able to run agents across the knowledge graph. Anyone want to take a stab at, are you doing anything with knowledge graphs explicitly, or you're...
No, I don't really understand knowledge graphs either.
Okay, all right.
I would like to.
We have a partner company with IOTA that's working a lot in the knowledge space. It's really what it's able to do is pull together the complex relationships, not only from an asset perspective and maybe a procedural perspective, but also the relationships of information that go into those processes, whether it's raw materials, MES information, recipe information, and then certainly some of the outputs of what's produced, right? So it's kind of a sort of a holistic view of all the different relationships that may apply to anything in different types of business, whether it's manufacturing processes and things like that. So it's a really complex matrix of information that you can sort of draw from and understand, potentially, like how does a one product yield get better with a different raw material? What raw material was used? How can you potentially use AI and analytics to then characterize a process around optimal raw materials or suboptimal raw materials? So there's a lot of cool things that those kind of capabilities can bring up.
Yeah, I know it's a hot topic in the Open Asset Digital Twin group. They had specific conversation around, is there a standard for knowledge graphs, and how do we think about that moving forward? Knowledge graph being part of the, obviously, asset digital twin. Lucas, it looks like...
Yeah, just to add up, right, I think it's also about the relationships and what they mean and what's the historical information, right? Like we just started a relationship. She asked a question, right? We can know what's her role, when the question was done. So what's the relationship that was created, what this means, right? And that's powerful in this context of answering questions, right? Because you can add all of this context that in traditional database is not really possible without a deep knowledge about the database, right? This can be inferred by LLMs based on this relationship that's created between two different assets or people. Or
I do want to maybe change gear a little bit, right? I didn't mean to derail us, but I just keep talking about knowledge graphs, and I thought we better ask that question. But what's the different approach? Because actually it prompts another question, which is using the knowledge graph to kind of infer context or create that context to make the Gen AI model more accurate. But the other approach that we've heard, unfortunately Cummins didn't present, but I know there's a lot of passion in the room about causal AI. So talk about how you do that with causal AI in terms of making the connections. Because one of the challenges we have is Gen AI is great, but we don't always know where the answer came from, right? Or how it arrived at the answer. So there's a number of use cases, particularly in pharma and regulated industries, where you have to be able to show why a decision was made and needs to be explainable and auditable. So you want to spend a minute talking about that?
Absolutely. So before understanding that knowledge graph, let's look at this genesis of this graph. So genesis of the data structure. So we started the data structure is a flat file or the in memory. From there, in memory we came to this flat file structure. Then we came out with this RDBMS, which is a inflection point for any data based analytics. So then we move to the graph. Graph is basically a cyclic data graph, like A connects to B, B connects to C, right? So now if we can store all this information, so we can use the different graph theoretic, graph analytics approach to find the right information quickly. So now the next phase for that is knowledge graph, which Google introduced almost a decade ago, right? So now the challenge is, what do we consider as a knowledge? Do we consider data as knowledge or something else? So now if we just kind of map it to our human decision making, we humans, we do not make a decisions based on data. We make a decision based on that pattern. If we are storing that pattern in a knowledge, so that is the knowledge. So now we are cheaply sometimes that we just look at the data or look at that kind of the sum of this, we use this language model to strip a sentence to find out few entities and say A connects to B, we put it in that knowledge graph. Yes, that's a surface level knowledge graph, but that is not the deep knowledge. So now if we can find out the deep knowledge, why something is happening, what is causing what, or one particular event can be caused by 5 different root causes. So now if we can capture that with the I would say conditional probability, not all the events will happen together. So then we can store it in the graphs. That becomes, in our language, that becomes a causal knowledge graph, which is another form of knowledge graph. But now from the commercial standpoint, is very important. Like if we spend 5 years and $5 million to create a knowledge graph for a function, that has never been commercially viable. So now this important thing is how we can automatically generate that graph, at least 80% automatically. So that is basically becoming that inflection point for any analytics that we can build on knowledge graph.
Okay, great, thanks. Any other questions from the audience? Alex is still hovering with a microphone. Sid at the front here.
Yeah, I'm Sid Snitkin with ARC. I'm cybersecurity, but also AI. I like AI too. As I was watching, I was very, very impressed with this presentation. Very impressed. But I wonder, like when you have something, I mean, in the past, people would store away knowledge. Like you might go to an engineer or a maintenance person and say, "Tell me if I see this, what's the cause of that?" Or you do it in some other way, and and I think companies have probably been doing that for many years to store that information. I mean, it's hard to access it. So, but when I saw some of the stuff, like particularly the one that figured out it was a problem with a pump and it was corroded. I mean, that's super impressive, to be honest. But in the end, when it starts telling you what to do and how to fix it, how much of that is actually generated by the system versus information that's in the system already from knowledge, other kind of knowledge capture? You get my gist? I'm not explaining it well. I hope you do. I mean, it's like a work order. If you have a work, people like in maintenance systems for years, they put in a work order, you should be doing this, 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 and that. Now that's fine, and then somebody will determine that you should do the work order. Then you can pull out all the instructions.
Let's start with Ibrahim, and I think there's a logical follow-on question on how you capture
So,
expertise, right? Yeah.
So LLM has inherent knowledge depending on what you're doing. So if you go to ChatGPT, you can ask ChatGPT about how to troubleshoot a pump. What you will get is a lot of generic answers and may not be relevant for the specific pump. So you have to take that knowledge, right, and you have to then tweak it to make it relevant for your company, for your pumps or things that you want to achieve. And that's the marriage that we do. Take the trained model, fine tune it or pre-train it or do whatever with it to create the experience that we want. We don't want operators getting an advice from Joe, open up the pump and check something. Like, it's running. We want it field practical stuff. If you ask ChatGPT and we tested it, it will give you advice that may not be executable in the field, right? So that's what we did. So we paired the knowledge and experience that our rotating equipment engineers have on top of the LLM to create the responses that we have. The other thing we're doing in the agentic framework is we're not just using generic models. We're also using SLMs and other things and machine learning for different prompts and things like that.
Can I perhaps just, I'm assuming you're using RAG, you're using fine-tuning with using RAG or pre-training, and then you're probably doing some prompt engineering as well, right? To get more accurate results. And then it's not, as you just said, it's not all Gen AI, right? And when it makes sense, you're going to use other techniques. I think another part of your question was, though, that's great when you can pull it out of documents and it's been stored, right? But it's in somebody's head, and I think that's where maybe you want to add a different perspective from a causal AI perspective, because I think that's one of the areas where I certainly see that it's operators and experts are more willing to accept the results, right, from causal AI, because there is a logic, there's a causal trail that they can follow.
Right. So that starting from to answer to this question or give a kind of different color to this your question. So let's start from the kind of the source of this knowledge. So if you are looking at this document may be right, may be wrong, maybe partially right, partially wrong. So the other source of information are the experts. So we believe that experts run that business, so not the documents. So now talking to the experts, and if you talk to the different operators, process engineers are orchestrating the different functions across that business process or the process control, capturing their nuanced response to a kind of very specific type of questions, that becomes like their answers become one kind of source. And obviously the other kind of source are like the procedural process documents, PFID diagram, PNID diagram or PFD diagrams and all this stuff. And obviously looking at the data. So now you aggregate that operators' experience and the documented knowledge plus data together, then you get a holistic understanding of that knowledge, right? Which we can reuse. And obviously, like when you are making a decision on a process control, our accuracy has to be 100%, right? We cannot say that, okay, this is basically if then else, that's not going to work. So that multimodal knowledge aggregation or knowledge discovery is very, very essential for using in the process control. That is the differentiating approach that causal knowledge graph is providing for any of these analytics.
Okay.
Could I just follow up? I don't want to. Oh, it's just. I mean, I have a background in AI a long time ago. Okay, but when people talked about expert systems, and I've tried to develop them myself, I know people who have, and it is incredibly time consuming because it started by talking to the expert and saying, here's a problem, what do you see there, how do you diagnose? It's like in medical stuff. There's all kinds of systems where that's been done. And they haven't been successful, I don't think, or maybe for the reason you said, they're just far too costly to build, they're too slow. So I'm just wondering, how do you do that? Because you can't just look at a diagram and make...
Well, I think what you're referencing, Sid, is really that arguably expert systems started with those rule-based systems, but it got incredibly time-consuming and complex to just have layer after layer after layer of rule, and it just wasn't scalable. And you had all sorts of problems with keeping them up to date or changing them. They weren't very dynamic, right? And so that's some of the benefits we're seeing in foundation models is they can take massive amounts of data and they're not perfect as we're hearing, right? But they can do a pretty damn good job of going over massive amounts of data. And you can fine tune it. So you can say, don't just take the generic model, take my documents and train and learn my particular pump naming scheme or the language that I use as a pharma company, rules and regulations. So they can adjust the language and make these systems much more accessible. I think in the case of Parable, their methodology with causal AI means they can do a lot of the connections and root cause analysis now at scale. The next wave we kind of talked about on the opening slide, things like neurosymbolic AI are promising to combine the benefits of like Gen AI, but add back some of the rule-based logic so that you can, again, get higher accuracy and build in more logic. So did I get that wrong, or anything you want to add to that?
I just think that I think what you just shot, whatever we showed in terms of Joe AI, it was actually built in a very short amount of time, precisely because we have access to foundation models that we can use that already have knowledge. You can then target it for your use cases. I think the biggest challenge with Gen AI is the hallucinations, right? And the way we have trained our Joe AI is we rarely get hallucinations. We might get no answer rather than a wrong answer, and that's how we work our problem around hallucinations. And it's worked quite effectively. And I think the other thing around is what people forget is that when a rotating equipment engineer tells you something, you don't ask him to explain why he's saying something, right? Because you trust his experience and knowledge. And I think we try to hold AI to a much higher standard. And I think AI can make mistakes right now. Humans can make mistakes. And that's why AI is not autopilot. It's still a co-pilot.
Any other questions from the audience? Right. Any other questions from the audience? I was really interested in what you're doing real time, right? So not that I'm diminishing anything anyone else has done, but there was, I think we started off with Devon Energy. I do want to kind of come back to some of what you've built. I mean, that amount of data being available within a couple of seconds from Pi and then making it accessible to everybody through whichever their preferred access tool and methodology is, in my view, very impressive, right? What do you think your next steps are? Are you looking at what Ibrahim did and you're now going to layer that on top of it? Because you've got a really solid foundation there.
Yeah, let me just say first off, that was super cool. Joe AI is awesome. Yeah, we want it. Right, Devin, guys?
It's on sale by Radix.
Good. Yeah, I mean, I think the future steps would include, that kind of a tool set. I also mentioned we want to do some closed loop control based on outputs from some of these models, those more advanced models that aren't already happening inside of our Pi system. It's pretty easy to orchestrate the calculations that are happening in Pi, but orchestrating all of those models that are happening maybe on the Databricks side or in Seek or in some other system where we're solving that problem, those are harder integrations to make happen in real time, and so that's an area we'll spend time in as well.
I guess you mentioned two different perspectives, but you talked about human-centric, right? You kind of hinted at it as well, because it was like, give each of the different users or personas whatever they're comfortable with to access the same core data fabric that was underneath it. So are you thinking about something like Joe AI as like a unified interface, or you still think it makes a lot of sense to have those role-based?
More agent-based, where you select the persona that you are?
Agent-based, yes, but also not one unified interface, but hey, I've got engineers that need this set of tools and data scientists want a different set of tools. So it's not exactly the same thing because you're more user-focused, right?
Yeah, we're very much prompt-based.
Yeah.
Yeah. I don't really work in generative AI, so I probably don't know what the art of the possible is there, but I really liked that you didn't need to really know what agent you needed to select, and
right.
You just talk to it and it figures it out, goes and uses the proper agent, as it does that. I've got lots of questions about how that works, and yeah, it's really, really cool.
Okay. It sounds like you've got something, Lucas.
Yeah, I think that is one interesting use case that we are working to integrate real-time data with Gen AI and machine learning and machine vision, I'm sorry, or computer vision, which is one of the pellets producing facility, right? They want to make sure that the pellets goes out with the proper quality, right? So there are string cameras that are taking pictures in real-time sampling, right? And we want to integrate computer vision to analyze the quality of that sampling of the samples, right? And see if you have like wrong shapes, colors, or anything like that in the pellets, right? Combine that with models that are looking to the time series in real time and checking or predicting the quality of the product, which usually takes some hours, and at some point you might be like 12 hours without knowing the quality and lose all of that production, right? And where Gen AI comes is how you can prompt, and ask questions in natural language to know not only what's happening, but how you can fix it, right? You might have problems of like your blades are not working properly anymore. You need to replace them, or depending on the shape of the pellet, right? You might have different root causes that are mapped. Because you have years of experience. But how you can make that connection faster in analyzing all of these types of data, Gen AI can help, and can provide reasonable explanation to someone that may be new to the process and need to learn something faster, right?
Computer vision, right? You were using quite a bit of it, so you must be using some mixed mode models and multimodal, right? And then it sounded like you were getting into machine vision on the end there, Don, right?
Yeah, we've done image analytics for several years now, but adding Gen AI to that as another set of eyes is new to us. But we're finding that it works pretty well.
Any last questions? I'm sure you can come up. I think you offered that if anyone wants a co-pilot, your Joe.ai demo. I think we are hooked up here and can actually, he can go and show you it for real, not just the video. So hang around if you want to do that. I think we should probably wrap it up. I think we are just about on time, but I think maybe just a closing thought on what's next. You can start if you like, right? Or if you don't, we'll start with the other end of the.
Yeah, I think for us, we in the next steps in the near future, we are trying to make our Joe AI more and more embedded in our organization, more mainstream. There's a lot of change management that needs to be done in terms of trusting it, using it, and really rethinking how we interact with digital technology and drive value for our business. So that's the journey we're on. We've done a lot in a very short amount of time. And a lot of that is what you see is not like, you shouldn't be scared of it. I think if you have the right platform, the right partners, and the right data put in place in a very short amount of time, you can make miracles and magic happen. You just need the will to do it.
Let's just go this way. So, Lucas, do you want to?
I think what we are working on right now is really to scale the AI models, right? So Gen AI is there; it's connected to the data, but how can we deploy models across the organization and roll out them in an easy way and connect them to the main frame, which is Joe, right? So I think that's what we are targeting and planning to scale and harness the ROI that it can provide, right? So,
right, Michael.
Yeah, I'm kind of been out of the AI business for a little while, but I kind of see. First of all, I see that Gen AI has sort of caused a little bit of a shift, and I mean, I may call it a distraction. I see a lot more value in it now with Joe.ai. So I mean, it's really amazing what you've been able to do. And certainly my buddies back there at Seek are doing a lot of crazy cool things too with Gen AI and enhancing the experience of operators and engineers. But I see that I mean, I come at from the context of supporting pharma and life sciences for the last decade. And, to your point, Colin, we need, that definitely requires explainability and understanding of how the model works. And so, and if pharma can do it, anybody can do it. So I see that, a lot of the push is going to be more towards closed loop optimization, or at least prescriptive analytics with maybe a supervisory operations in place, but more prescriptive, more, changing set points, recommendations based on sort of graph-based models or database models, and sort of expanding that out to trying to sort of optimize based on the knowledge, optimize recipes for certain situations, building more robust processes and adaptable processes. So I think that's probably the next really best vision for use of operational AI in practice. And so I hope that we'll get there sooner than later. And for those in life sciences, FDA has recently produced some guidance. So if they want to do it, then the manufacturers should do it.
Okay, try and keep it brief because I think we're running out of time.
So in 2025, I see that 2025 is going to be an ensemble mix of AI technologies to come together and solve that industrial problem, right? So where it comes to this human interface, GenAI is great, is doing this one, but when it comes to this forecasting or decision intelligence for the process control, and as you said, this different type of operational analytics, there it needs the math and logic. For an example, optimization, I would consider that as a pure math. So those things will complement this, all of the technologies to achieve that ultimate objective of efficiency.
Okay, thanks. And what's next for Devon Energy?
Yeah, I'd say in the medium to short term, we'll be focused on building probably agents, Gen AI agents that interact with our data systems, specifically purpose built for whatever those agents will be. And then it sounds like maybe I need Drew to get his checkbook out and we need to go have dinner with Radix.
Okay. Thanks for that. A round of applause, please, for great customers.